Hello everyone, myself Atul and I welcome you all to IMS Academy YouTube platform. Simple mechanism is one of the most important part of the theory of machine subject. Every year in the GATE examination you will find one question from that topic. And such questions we can solve with the two different approaches. First is velocity diagram approach, second is eye-center approach. In eye-center approach we will be using angular velocity ratio theorem. And I have seen many students find it difficult to apply that theorem. So in this particular video, we will be discussing in detail about the angular velocity ratio theorem and we will solve some previous year GATE questions. Okay, and I can guarantee you this thing, if you have watched this video completely, then you will never face again any challenge while solving questions related with the angular velocity ratio theorem. Right, so let's get started here guys. First of all, we will see the definition part of the angular velocity ratio theorem. So, angular velocity ratio of two links relative to the third fixed link is inversely proportional to the distance of common eye center from their individual eye center with respect to fixed link. So, that is what the definition part. Now, let us see how we can write down the ratio. Let us consider first of all a 4-bar mechanism, link 1, 2, 3, 4, link 1 is fixed, right. Now, if I have to write omega 2 by omega 3, how I will write? First of all, the common eye center will be I23. So, distance of I23, that is common eye center from the eye center of link 3 with respect to fixed, that is 13, divided by the again common eye center I23 distance from the eye center of link 2 with respect to fixed, that is I12. Okay. Consider one more example here, omega 2 by omega 4. How we can write? Right. So, common eye center is I24, distance of I24 from the eye center of 4 with respect to 1, so I14. Again I24 common eye center, distance from the common eye center from the eye center of link 2 with respect to fixed, I12. Now, consider one more example, omega 3 by omega 4. Common eye center is I34. Distance of I34 from the eye center of 4 with respect to 1. Again, common eye center I34, distance from the eye center of 3 with respect to fixed, that is 1. So, in this way we can write down the ratio of angular velocity. Now, to use this relation we need to know the distance, and to know the distance we need to locate the eye center first. Now, we will understand how we can locate the eye centers using Kennedy's theorem, right. And what is Kennedy's theorem? In Kennedy's theorem we will understand that if any three links are in relative motion, then their eye centers will lie in a straight line, right. So, again we will take one 4-bar mechanism here and then we can understand how we can define or how we can easily locate the eye centers, right. So, 1, 2, 3, 4 links, link 1 is fixed here. Now, in a 4-bar mechanism all are pin joined. So, I12 is here, I23 is here, I34 is here and I14 is here, right. So, these are the eye centers. Other eye centers I24 and I13 I need to find out, right. So, let us start here. First of all, link 1, 2, 3 I am considering, link number 1, 2 and 3, right. So, the eye center 1, 2, 1, 3 and 2, 3 will be in a straight line. So, out of 1, 2, 2, 3 and 1, 3, which of the eye centers are available? Please see, I12 is available, I23 is available. So, all three including I13 also will be in a straight line, but I have two eye centers, so I can draw one line here, okay. So, I can easily draw one line, fine. So, let us consider this is one of the line using 1, 2 and 2, 3. I13 will be on this line itself, but at this moment I do not know where it will be, right. Now, another link I will consider, link 3, 4 and 1, link 3, 4 and 1 we will consider. So, the eye centers like 3, 4, 1, 4 and 1, 3 will be in a straight line. 3, 4, 1, 4 we have directly available in the mechanism itself, 1, 3 we do not know. Now, but you will find 1, 3 is also available here, 1, 3 is also available here. So, wherever both the lines will intersect, that point will be the I13, right. So, 1, 4, 3, 4 is available. Using these two eye center, I will again draw one more line, and where it is intersecting, that point will be the I13. I hope this point is clear, right. So, locating eye centers is very easy if you have understood the motion. So, you need to know how to visualize first of all the motion in a mechanism. So, these are the pin joints. So, for 4-bar mechanism, this much basic knowledge you should be having, that this is the all are pin joint, there is no sliding joint. Now, okay, one more point, if it is a sliding joint, eye center will be at infinity, right. perpendicular to the sliding motion direction, eye center will be at infinity. So we will simply draw one line perpendicular to the sliding motion. Okay, like that we will do. So basic knowledge of the eye center we should know, then only we can easily locate the eye centers. And one important point you can note it here, that eye center always lies on a line perpendicular to the velocity vector. This is a very important statement, you can note it on this point also. Okay, I hope at this point everything is clear. Now coming to the next part, 1, 3 we have located, now 2, 4 also we want to locate. So let us consider the link 2, 3, 4. So eye center 2, 3, 3, 4 and 2, 4 will be in a straight line, right? So we can draw one line because we have 2, 3, right? We have 3, 4. Those eye centers are already available. 2, 3 and 3, 4 is available. We can draw one line using that two different eye center 2, 3 and 3, 4. That line. Now another link I will consider 2, 1, 4. What are the eye centers? 1, 2, 1, 4 and 2, 4 will be in a straight line. Again, wherever these two lines are going to intersect, that point will be 2, 4 because that common point is 2, 4 only, right? So using 1, 2 and 1, 4, okay, 1, 2 and 1, 4, I will draw one more line. Where it is intersecting, that point will be considered as I, 2, 4. Again, I am telling you, locating eye center is very easy if you have understood the Kennedy's theorem. So Kennedy's theorem is, whenever three links are in relative motion, all of the eye centers will be in a straight line. Okay, now moving ahead here. Now we will directly see this question from the GATE 2023, right? In this particular question, they have given one mechanism and they are asking the relation between omega 1 and omega 2. Okay, so we will solve this question with the help of angular velocity ratio theorem. Now look at the question here first of all. So figure shows a wheel rolling without slip, okay, on a horizontal plane with the angular velocity omega 1. So they have given this disk omega 1 velocity. So let us consider this disk as a link number 1. And for that rod, they have given omega 2. So consider that rod as link number 2 and link number 3, which is a horizontal plane, which is fixed here. So that is 3 here. Okay, fine. Now one more point, a rigid bar PQ is pinned to the wheel at P. Pinned means what? Hinge or pin joint, right? So at P they have mentioned, while Q is sliding on the floor, that point Q is sliding on the floor. So sliding motion is there, right? So reading the question is also very important because some of the important information you will be getting from the question and some information you will get from the diagram also, right? Because if we have not understood the motion, if we are not able to visualize what kind of motion it is going to do, then it is impossible for us to locate the eye centers. I hope this point is clear. Now they are asking what is the angular velocity of omega 2 of the bar. So basically omega 2 and omega 1 relation they are asking. Okay. So what I have told you in angular velocity ratio theorem, we need to first locate the eye centers. How many links? 1, 2, 3. Total 3 links we are having. So we need to locate all the 3 eye centers here. Okay. Now see. This is the given mechanism we are having. Okay. First of all, if I consider link 1, 2, 3, obviously in relative motion, so link eye center like I12, I13 and 2, 3 will be in a straight line. Okay, fine. Using this 2 points, I will draw one line. Okay, now you will be asking, sir, why this line you have considered from R and P only? Because P is a pinned point, right? So as I've already mentioned, this wheel is our link number 1. This is link number 2, right? So this point becomes our I12, right? And this disc is rolling on a horizontal plane. So the point of contact will also be a eye center here, which will be I13. So I12, I13 I have find out. So using these 2 points, I will draw one line. Now the third eye center, which is I23, will be on this line itself. Now again, closely observe this mechanism. Q point is sliding on the plane. So I've told you, wherever the sliding motion is there, perpendicular to sliding motion, we need to draw one line. Okay, so we will draw one line here, and this line is intersecting with this line. So this point will be our I23. So all of the eye centers we have located here. I hope this much is clear to everyone. All of the eye centers we have located. How we have located? P was the pinned point. So this point is itself the eye center, I12. I13, how it is there, eye center? Because whenever disc is rolling on a horizontal plane, the point of contact is the eye center. So eye center, I13, it will be there. So like that, we have drawn one line using I12 and I13. So we got I23. and Q point was sliding, so perpendicular to sliding motion, one line we have drawn. Finally, both the lines are intersecting at this point, so that is I23. Fine. So till this point we have understood. Now we will be using angular velocity ratio. Omega 2 with respect to omega 1 relation they are asking. Omega 2 by omega 1 I will write here, right? Okay. So omega 2 by omega 1 will be what? Common eye center I12, right? Distance of common eye center I12 from the eye center of link 1 with respect to fixed. Fixed is 3 here. The fixed link is 3. So I13. Again, common eye center I12, distance from the eye center of link 2 with respect to fixed, that is I23. So here the biggest challenge is how we will get the distance of I12 from I13. I12 is here and I13 is here. Okay, fine. I12 and 23, I12 is here and I23 is here. Here the most important part comes, that is the geometry part, right? So this much you have understood, you have located the eye center also, you have written this angular velocity ratio theorem also. Now you need to apply some basic geometrical properties here, so that we'll get this distance here. Okay. Now let us consider this as a equation 1 here, right? Now what I will do, let's suppose if I draw a horizontal line, let's suppose this is my horizontal line, and wherever it is intersecting by this vertical line, I am considering that point as x, which means this point is x. Now if you closely observe the triangle X, P and I23, the triangle X, P and I23, and another triangle O, P and I13, two triangles, please closely observe the two triangles X, P, I23, another triangle O, P and I13. These two triangles are symmetrical triangles. Why? Because two of the angles are same. This angle same, and this 90 degree and this 90 degree. So we need to know the similar property triangle rules, right? That is basic part. That much we need to understand. So as I've told you, these two triangles are similar. I can use the similar property triangle property, and we will try to find out this distance here. Okay. So triangle OPR. OPR, R is what? I13 only. Okay. And next another triangle is XP, I23. These two are similar. Now considering these two triangles, what relation we can write here? Please try to observe. Distance OP equals divided by XP, OP by XP equals to, very important point, PR divided by PI23. Now OP distance and XP distance. Can I write OP and XP? Yes. OP is what? 2 meter already given. Can I write XP distance? Yes, it is 8 meter given. So OP value is what? 2 meter and XP value is 8 meter. This is already given in the mechanism itself, right? Now what is PR? P is the point I12 and R is I13. Okay, it is the distance between I12 and I13. I hope it is clear, everyone. So this is I12 and this is I13. Now P again, P is the I12 point. So this is the distance of I12 and I23. And what we need to find out? 1, 2, 1, 3, 1, 2, 1, 3 and 1, 2, 2, 3. Yes, this ratio already we got it from the similar property triangle rule. Now we will be using this relation here to get the omega 2 by omega 1 answer. So I hope you are getting the concept here, how we can write angular velocity ratio theorem, how we can locate eye centers, and after finding the location of eye centers, we need to calculate the distances. For that, some basic geometry properties we need to understand, right? Now next. So 2 by 8 it will be there, because this is what? I12, I13, I12, I13, I2, I12 and I23. So that ratio is equals to 2 by 8. So directly I will write 2 by 8 here. Okay. So omega 2 by omega 1 will be what? 2 by 8, right? Omega 2 by omega 1 will be 2 by 8. And finally your answer will be equals to omega 2 equals to 0.25 times of omega 1. So that will be the answer of this particular question, which was asked in GATE 2023 examination. Right? I hope everything is clear in this particular question. So we will see the options here. Okay. We will write here. Yes. Option D will be the correct answer here. Option D is the correct answer here. Now one more numerical we will solve, which was asked this year itself. GATE 2024. Again, very good question they have asked. And many students actually find it difficult to solve that question. But I am telling you, if you stick to the basic part, basic fundamental concepts, you will never face any challenge in any of the problems, right? as in our GATE syllabus already mentioned simple mechanism, which means only 4 links will be there. So mechanism which will have up to 4 links, okay, those are called simple mechanisms. If more than 4 links, it will be compound mechanism will be there. So in our syllabus, whatever the questions will be coming in the GATE examination, it will have only 4 links. So we don't need to worry about the given mechanism that it is very complex. No, it's not like that. If you have understood angular velocity ratio theorem, you can apply anywhere, right? So let us move on to the next question here, which was asked in GATE 2024, right? Okay. Yes, this was the problem which was asked in GATE 2024 examination for 2 marks, right? Now, maybe many people will find it difficult, or maybe they are confused how the motion will happen in this particular mechanism. So please read the question very carefully first of all. Okay, before looking at the diagram, we will first read the question. So at the instant when OP is vertical, yes, OP is vertical, they have mentioned itself, and AP is horizontal, AP is horizontal, this AP is horizontal and OP is vertical. Okay, correct. Whatever they have mentioned, it is easily we can understood from the diagram also, right? The link OD is rotating counterclockwise at a constant rate of 7 radian per second. Link OD, which means this yellow one, OD is rotating counterclockwise with 7 radian per second angular velocity. Pin P, yes, okay, this is the pin P, is going to slide, okay, they have mentioned on the slot BC. This is the slot BC is available, on that this P pin is going to slide. That is what they have mentioned, and we can understand from the given mechanism also. So while reading, also try to see the diagram, okay, you will understand and you will be able to visualize the motion also, right? So pin P on the link OD slides in the slot BC of the link ABC. Link ABC, ABC is a complete link, okay, don't consider it as like a different links. ABC is a complete link, fine. Now next point what they have mentioned, which is hinge, link ABC is hinged at point A, okay, fine. Link ABC is hinged at point A, fine, okay, understood. Causes a clockwise rotation of the link ABC, fine. The magnitude of the angular velocity of link ABC for this instant, okay. Finally they have told find out the angular velocity of link ABC, right? Now again, how many links will be there in this particular mechanism? First, if I mention here, this is the fixed link, you can consider this as a fixed link. You can consider this as link number 2. You can consider this as a link number 3. Okay, and this again fixed will remain same. So total 3 links are available here. We can easily apply the angular velocity ratio theorem, but before that, location of eye centers is important here. Okay, let's see how we will define the location of eye centers. Link 1, 2, 3 are in relative motion, so 1, 2, 1, 3 and 2, 3 will be in a straight line. Yes, absolutely. Okay. Now, this is one of the eye center and this is one of the eye center. Why? Because these are the hinge points, right? So directly I can mention here, as I told you, this is the link number 1 I have taken, this is link number 2, this is link number 3. So this eye center will be the I12 and this is I13. This is the eye center and this is the eye center we are having. I hope everything it is clear up to this point, right? I12 and 13 is available, so I have joined both the eye centers and I will get the straight line. Now I23 will be on this line itself, but how to get it? See, they have told this pin P is sliding in the slot BC, so sliding will happen. So to get the eye center, what we will do? Perpendicular to the sliding motion we will draw a line. Perpendicular to the sliding motion we will draw a line. So perpendicular to the sliding motion I have drawn this line, correct, till this point. Okay, fine. Both the lines are going to intersect here, so that point will be I23. Okay, so that point will be I23. I hope it is clear everyone. Till this point everything is clear to everyone, right? So link 1, link 2, link 3. So that point will be I23. So 1, 2 we have defined, 1, 3 we have defined, and this is what 2, 3. Got it? Now, next thing, angular velocity ratio theorem, because what they are asking, angular velocity of the link ABC, which I have mentioned as link 3. ABC I have mentioned as a link number 3. So I can simply write omega 3 by omega 2, okay, using angular velocity ratio theorem. Common eye center is I23, distance of common eye center from I12, that is link eye center of link 2 with respect to fixed, that is I12, and common eye center I23, distance of I23 from the eye center of link 3 with respect to fixed, that is I13. So that is there, okay. But again the problem is how I will get the distance of 2, 3 and 1, 2 and 2, 3 and 1, 3. 2, 3 is here, 1, 2 is here, and 2, 3 is here, and 1, 3 is here. How I will get the distance? Okay. Now, first of all, this is 60 degree perpendicular. This is the sliding motion. Okay. This dotted line represents the sliding motion. Perpendicular to sliding, I have drawn this line. So if this is 60, remaining angle will be 30 degree. Please understand this basic part, everyone. This is 30 degree. Now this is 150, this is also 150, and this one line I have drawn. So this is 150, 150. Isosceles triangle will be there. This will be 45. So 30 plus 45, 75, remaining angle will be 105. Okay, fine. Now this is 30 degree. This angle will be 60 degree. This angle already we have defined. 45 degree. 60 plus 45, 105. Remaining angle will be 75 degree. So in that way, we have defined all the angles. Now, I've told you also, now what we can do, we can apply the sine rule here. Okay, we can apply a sine rule. To get the distance of I23 and I12 and I23, 13, simply apply the sine rule, you will get the answer. So this much basics of geometry part, sine rule of a triangle, cosine rule of a triangle, this basics we should know in order to solve simple mechanism problems, right? So in triangle PI13, okay, in triangle PI13 and I23, I can apply sine rule. So if I apply sine rule, this relation I will be getting angle opposite to PI13 will be 105, and angle opposite to 2, 3 and 1, 3, 2, 3 and 1, 3 will be what? 30 degree. So from that I will get the distance 2, 3, 1, 3. Distance of common eye center I23 from I13 will be 77.64. In a similar way, I will apply the sine rule to this triangle also, PI23 and I12. Okay. So that sine rule I will apply, and I will get the distance also. Okay. Distance of I23 and I12 I will get. So again see here, P and I23, opposite angle is what? 45 here. And angle opposite to PI12 is what? 75 here. So what I want, I23 and I12 I want, so angle opposite to I23 and I12 is what? 60 degree. And which distance I know? P and I12, that is what? 150, and opposite angle is 75. So if I apply the sine rule, I will get the distance of 2, 3 and 1, 2. 2, 3 and 1, 2 I will get. So that distance is what? 134.48. So all the distances we got it, right? This distance 2, 3, 1, 2 and 2, 3, 1, 3 also we got it. So 2, 3, 1, 3 is 77.64. 2, 3, 1, 2 I will be getting from this triangle P, 2, 3 and 1, 2 by applying the sine rule, right? And after that we will directly put the values in the main relation, equation number 1. So that was 134.48. From equation 1, we will directly put the values here, and from that we will get the answer of omega 3, that is link ABC, as 12.12 radian per second. I hope the solutions are clear to everyone. Okay. So in this video, we have talked about the application of angular velocity ratio theorem. This particular topic is very, very important in the theory of machine subject. Every year you can just see last 5 year or 10 years paper. Every year you will find one question from the simple mechanism where they will be asking angular velocity of any particular length of a given mechanism. In such problems, angular velocity ratio theorem plays a very important role. So after this video, you will never face any issue, that I can guarantee. If any doubt if you have while covering this particular topic, you can mention in the video itself as a comment. We will try to resolve it, okay, as soon as possible. I hope whatever we have discussed about angular velocity ratio theorem is clear to everyone. Okay, you can join the Telegram group where you will be getting all lecture PDFs of YouTube sessions. Apart from that, you will be getting all latest job notifications, and daily quizzes will be running which will help you in your GATE preparation. So link is provided in the description of the video. You can click on that link and join the Telegram group. We have started our live online program for the GATE. 2025, where you will be getting 800 hours of live interactive sessions where you can ask your doubt in the live class itself. You will be getting theory book, exercise book and a GATE question bank. And most important feature of live online program is the mentorship sessions, where you will be always in touch with your faculty, and the faculty or the mentor will be guiding you in your GATE preparation. And online test series, more than 130 online tests you will be getting, starting from the chapter level, subject level and the final full length mock test. And one more important feature is the live doubt solving support, where you can just post the question image and you will get the solution. So if you are interested in the live online program, you can directly book a free counseling session by contacting on this number. Okay, I hope you got the information. Thank you so much, guys.